We've been looking at quadratic functions, which is y equals some x squared piece. But in 11.2, we're going to look at circles and ellipses, and this is a little bit different because they're not functions, right? A circle is not a function because it fails the vertical line test. An ellipse is not a function because it fails the vertical line test. But in these cases, the circle and ellipse do have x squared. So for example, the base form for a circle looks like this. Okay, and let me just double check. Yeah, I thought that might be the case. Both subtract. And then for ellipse, so this is for circle, and then for an ellipse, it looks like this. And there's actually two, and we'll talk about in a second what the difference is. And I forgot what that last piece is. Just one. Okay, and so we're going to go over circles first, and then we'll talk about ellipses. Okay, as I mentioned before, this is the equation for circles. Now, there are some elements of things that we've seen before. H and K. Before, H and K with quadratics were the vertex. So in this case, H and K is the center point. And that's what makes a circle, is we have one point, and then every other point on the function is going to be the same distance away from the center point. If I could draw, well, those would all be the same. And when I drew my circle, the outside would be the same. So the center point is H and K, and the rest of this function is telling you where all these points outside fall. So R is going to be radius. So we have center point, H, comma, K, and we have radius, R. The problem, though, is most functions are not given to us like this. So let's look at an example, and then we're going to use something called completing the square to make our equations look like this. So an example from the book would be like x squared plus y squared minus 16x plus 14y plus 32 equals 0. Okay, now I have to do some things first. First, I'm going to write it like this. I'm going to try to get the x's by themselves, the y's by themselves, and all the other information on the other side. Okay, so here's an x and here's an x. So I'm going to write those down first. X squared minus 16x. I'm going to give myself some space, and I'll make clear why I did that in a minute. Y squared plus 14y, some space, equals negative 32. And the negative 32 comes from me subtracting 32 to the other side. Now, what we need to do to find these two values is we have to do completing the square. Completing the square. Now, I don't like to use completing the square with quadratics because there's no reason to. However, in order to find this piece here, what I need to do, there's a shortcut here. It's 1/2 b squared. 1/2 b squared. That is the value that goes here. 1/2 b squared. So what is 1/2 of negative 16? That'd be negative 8. Negative 8 squared is 64. So I'm going to add 64. But what I do to the left, I have to do to the right. I added 64 here, so I have to add 64 here on the other side. Same thing here. What's 1/2 of 14? 7. 7 squared is plus 49. So I have to make sure to add the 49 as well. Okay, now, we know that this is a perfect square. If this is positive and this is negative, they're both negative. And so, hey, 1/2 of this number, it goes here. 1/2 of this number goes here. So I found 8 by taking 1/2 of 16. I found 7 by taking 1/2 of 14. Now I still have to add these two to this side. So negative 32 and 64 is positive 32. 2 and 9 is 1. 3, 4, 81. So 81. Okay? But 81 is what? R squared. So if I wanted to know, for example, if I asked you what is the center, you would say, oh, it's negative 8, 7. I'm sorry, I'm lying to you. I believe that it would be 8, negative 7. I'm sorry, because the original function is minus, so this is a positive 8. So it's just like before, when it's inside, it's opposite. I apologize. And so here, if this is positive 8, this would be negative 8. And then the radius, if I asked what is the radius, well, r squared is 81, so r must be 9, right? The square root of 81 is 9. And so our circle looks like this. 1, 2, 3, 4, 5, 6, 7, 8. And then 1, 2, 3, 4, 5, 6, 7. So here, but the radius is 9. So if I was going to connect all these, it would look something like that. Okay, and so this is the basic idea for circles. We want to use completing the square, which is 1/2 b squared, to find this outside value, which I have to add to the other side. And then to find this, I ask myself what multiplies to 64 but adds to negative 16. Well, that's just factoring from here to here, but we already know it because of 1/2 of this. 1/2. Okay, same thing here, and then we add it all up to get our end piece here. Okay, what I want you to do really quickly is to pause the video to write down these things. Okay, I want you to pause the video really quickly to draw this picture of an ellipse, label it like I have with negative A, positive A, B, B, C, and C, and then write out these 3 things. That the vertices are A and negative A, the intercepts, and then the foci. So pause the video really quickly, write these things down, and then we're going to talk about what they mean in just a second. Okay, so an ellipse is simply a stretched out circle where the distance from these 2 points, these are called foci. Focus. One of them is a focus, 2 of them is foci. And if I draw a line to connect this focus point to the edge, and then that point to this one, that distance is always the same no matter where you do this on the ellipse. I don't know about you, but that's kind of cool. So even if I draw it here and then here, those 2 distances are the same. These 2 and these 2 add to be the same thing. And so that's what the ellipse is. It's a stretched circle where there are 2 points where I can draw from those 2 points to one point on the outside, and that distance is the same all the way around. Now, as mentioned before, the vertices are always going to be these A values. So from 0 to this value would be a negative A distance, but we still have 0 because we're on the x-axis. This one is in a positive distance, so A and 0. Same thing with the y-intercepts. 0 for x because it's a y-intercept, and then y, and then a negative y with 0, and then the foci are C. Foci have a special condition, and that condition is that c squared is always a squared minus b squared. And so we're going to have to keep this in mind as well. So what I want to do really quickly is I'm going to erase this, but hopefully you've got that down. Okay, and I want to say, what if I have an ellipse where the vertices are negative 5, 0, and 5, 0, and the foci are negative 3, 0, 3, 0. So what can I do? Well, vertices are these A's, so I know I have A, and foci are C, so I know I have C. I have A and C. And so remember that piece that I just showed you was C squared equals A squared minus B squared. So if I plug in a C value, that'd be 3 squared equals 5 squared minus B squared. Okay, well, that's 9. That's 25, so minus 25 equals negative B squared. Negative 16 equals negative B squared. Get rid of the negatives. 16 equals B squared. 4 equals plus or minus 4 equals B. And so now we have our B pieces. So just from these two things, I know that my function looks like this, where this value here is positive 4, this is negative 4, this is 5, this is negative 5, and then these two pieces inside are negative 3 and positive 3. How did I know that? Because these are the x value, these B is the y, foci are also x, but they're inside of the ellipse. Okay, and sorry I didn't draw this, well, I'm not that accurate. Now, what about creating the equation? Well, I just need to look back here. Okay, so I have x squared over a squared. But a has to be bigger than b. Is that true? Is a bigger than b? Yes. So that would be a squared is what? 25 plus y squared over, what's 4 squared? 16 equal 1. And it always equals 1. And the reason it always equals 1 is because what we're doing is we're forcing this to be 1 to get these denominators. And in a minute, I'll show you an example where we have an equation that we have to move back to this kind of thing. Okay, so that's pretty much the basic structure. I want to quickly say that this is for horizontal ellipses. Okay, vertical ellipses have a few things that are a little bit different. Okay, so you can pause to finish up that piece, and then I will keep going. So vertical instead looks like this. Okay, and instead of having the pieces here and here be B, we're going to have those be A. Negative. And this one would be what? B0, negative B0. And then also these C values change. Okay, so you notice from here to here, the X and the Y values have flipped. Okay, X and the Y values have flipped. So this function looks pretty much the same. The only difference in this function is that it looks like this now. X squared over B squared plus Y squared over A squared equal 1. And this is the same. A bigger than B bigger than 0. So why does it make sense that this time the bigger one is with A? Because it's stretched up versus stretched out. So it makes sense that the bigger piece has got to be with the Y. Now, the vertices are just going to be the same A, but instead of 0, instead of negative A, 0, it would be 0, negative A, 0, A. The x-intercepts would be B0 and negative B0. And then the foci, these C points, foci are going to be 0, C, 0, negative C. However, the condition stays the same. C squared is still A squared minus B squared. Okay, that condition doesn't change. So now we've looked at horizontal and vertical ellipses. Okay, now I want to do an example real quick of a simple ellipse that uses these ideas. So the example I want to use is 9x squared plus 4y squared equals 36. Now, if you remember from the notes that we're just taking, these kind of ellipse functions always have to equal 1. So the first thing I need to do is get this to be a 1. So I get to divide everything by 36. 9 over 36 is really x squared over 4. 4 over 36 is really y squared over 9 equal 1. So now I can find A and B, or B and A. Which one is this? Is this going to be a vertical or horizontal ellipse? How do I know? Because if it's bigger under Y, it's vertical. If it's bigger under X, it's horizontal. So in this case, it's bigger under Y. So that means A equals positive and minus 3. B equals positive and minus 2. Right? Because I got to square root both of those. Okay, so now I have a start. 1, 2, 3, 1, 2, 1, 2, 3, 1, 2. So I know that my points are here. Okay, that's maybe a little bit better of a drawing. But what if I want to find the foci as well? I need to remember that c squared is equal to a squared minus b squared. Okay, well, a squared, c squared is 9 minus 4, which is 5. So c is equal to the positive or negative square root of 5. Now, I don't have an exact value for that, but I do know that it's bigger than 2 because square root of 4 is 2. So I'm going to just put my foci slightly above and below 2 and negative 2. So that's all we have to do for this kinds of problems. Now, these were all centered around 0, 0. So let's see if we can't look at a problem and figure out how to make it, how to come up with these pieces if it's not centered around 0, 0. And let's see what that changes. Okay, so we're going to look at an example where it may not be in the center. So what I want to do first is I want to put the x's together, and I notice that this x and this x have a common factor of 4. So I'm going to go ahead and put that on the outside. X squared plus 6x, leave some room, plus y squared minus 2y, leave some room, equals negative 21. I move the 21 over here. Okay, now I have to complete the square here and here. Okay, so this one's easier. It's 1/2 of negative 2 squared. Well, what's 1/2 of 2? Oh, okay. So what's 1/2 of 2 is 1. Negative 1 squared is 1. So plus 1. And when I add 1 to this side, I have to add 1 to this side. Okay, so I'm good with this. Now here, what's 1/2 of 6 squared? Well, that's 3 squared is 9. Okay, now what I add to this side, I have to add to this side. So add 9 But this 4 is distributed in here. So that means I can't just add 9. I have to do 4 times that 9. Okay? So, now what do we have on this side? We have 4x plus 3 plus y plus 1, and those are both squared. And I believe that I made a mistake here. Minus 1, because 1/2 of -2 is -1. Okay, now we just need to figure out what's on this side. So -21 plus 1, well, that would be -20. And this is plus 36, so that would be 16. Okay, so we have this plus this equals 16. But the rule for ellipse is that it always has to equal 1. So divide both sides by 16. Okay, 4 over 16. So x plus 3 squared over 4 plus y minus 1 squared over 16 equals 1. Now we have to decide, is this a vertical or a horizontal ellipse? Well, which one's bigger, under y or under x? Under y. So if I want to find my b value here is b equals plus or minus 2. A value, a equals plus or minus 4. But I can't just plot it on the x and y axis because we have 3 for our shift here and 1 for our shift here. So our shift to the left and right, well, this says plus 3, so shift is going to be opposite of this, so minus 3 would be 1, 2, 3. This is positive 1 or minus 1, so we know it's the opposite of this, so up 1. So the center is here. Left 3, up 1. Now, for x, I need to go left 2 and right 2. So 1, 2, 1, 2. For y, I need to go up 4 and down 4. So 1, 2, 3, 4. 1, 2, 3, 4. And we have our ellipse. Now, if I want to find the foci, c squared equals a squared, 16, minus b squared, minus 4. So c squared equals 12. So c is equal to plus or minus the square root of 12. Well, the square root of 12 is more than 3. So I'm going to go up 1, 2, 3, and a little bit. 1, 2, 3, and a little bit. And so there would be our 2 foci. And so the process here is the same, completing the square. Just remember, if you have a variable, or a number on the outside, when you move this to the other side, you have to multiply those two. Okay? So if you have any questions, shoot me an email. Come to the Zoom meeting. You know, we got those 2 days a week, Tuesday, Thursdays. So far it's just been mostly one person, occasionally 2. So come and join us. If you have questions about anything else, let me know. It seems complicated, but I believe in you. You can do it.